Hello students, how are you all? I hope you are doing absolutely fine. So welcome all of you at AriserTalent and I'm your teacher, chemistry teacher, Krina. So we were on the first chapter of the class 9 chemistry, that is about the matter in our surrounding. And until now, we have a discussion about a few of the experimental verifications or the experimental proofs regarding the characteristics of the matter. So in our previous lecture, we have discussed about what basic features or what basic characters any matter possesses. Now, today we are going to start about the classification of the matter. So, in the classification of the matter, basically you have heard that we have actually three states of the matter, that is solid, liquid and gas. But apart from that, there are two new states of the matter which will be invented further, that is plasma and BEC. BEC means Bose-Einstein condensate, which is the fifth state of the matter that was invented after the three states of the matter. These three states of the matter are you very well aware of it. It means solid, liquid and gas. These are the common terms we have heard about. But you have not heard about the term that is the plasma and BEC. So today we are going to discuss about the 5 states of the matter we have, their characteristics and what are their differences in the form of the tabular description. So let's start our classification here. So firstly, we are studying about classification of states of matter. So, matter is broadly classified into 5 categories. These 5 categories are solid, liquid, gas, plasma and BEC. These are the 5 states of the matter we have. So, these are the 5 states of the matter we have, and now we are discussing each state of the matter one by one. So, first we are starting with characteristics of the solid. So, our first topic is about characteristic of the solid. Now, you know that what actually the solid is. Solid are the substance, or solid is something that have a rigid structure. It means its structure will be tough. If I am considering this chalk, this is a solid. Why it is called solid? Let us assume the properties here, and you can also define the properties here. Firstly, the shape of the solid, it means it has a definite shape. It has a definite shape, it has a definite mass and it has a definite volume. So, these all three factors in case of solid are definite. So, we can say that any element, any compound, any type of the material which has the definite shape, definite size, definite mass and definite volume is considered in the category of the solid. And you know that its structure is much rigid. Now, what you can see in this chalk, you can see that the particles of chalk are very closely packed. So, it means if the particles are very closely packed, it is going to give you the rigid structure. Now, if the particles are closely packed, it means they have a strong force of attraction between them, and you can see that if they are tightly packed, the distances between them is quite low. So, we can see that the intermolecular separation in case of solid is low. Next thing is about density. If it has a definite volume, and you can see that how compact the structure of solid is, so we can also say that the density of solid is very high. Now, next point is about the intermixing of the particles. We can't diffuse solid into another solid. So, diffusion in case of the solid is not possible. Compression in case of the solid is again not possible. If I want that I can mix these two chalks, so I cannot mix these two chalks because they are the rigid structures we have. So the intermixing in case of the solid will not be possible. And if I want to compress this solid, as the particles are very tightly packed, you cannot compress the solid. So these are some of the basic features of the solid we have. And we have a variety of general examples in our day-to-day life regarding solid. If I am considering this wall, this board, this chalk, wood, paper, iron, everything, you can assume that which has a definite shape, definite mass and definite volume is considered as a solid. So let's write the some of the proper points here. So the first point we have about solid is a solid has definite mass, definite size and definite volume. Second point is solids are very rigid. It means their structure is very rigid. Now, if we are comparing about the next property about solid is that after having definite shape, size, mass and volume, it is very rigid, so the density is extremely high. Density is very high. Intermolecular distances are very low. But intermolecular force of attraction is very high. Solids are not easily compressible. So we can say that they are not compressible. And the next point is about they do not diffuse into another solid. So here these are some of the few characteristics of the solid we have. Now let's move to our next category, that is about liquid. The category of the liquid will possess the opposite properties as compared to the solid. Now if I am talking about water, alcohol, juice, ink, milk, these all are the category of the liquids we have. So liquids are those substances which have definite mass and volume, but they do not have definite shape. Suppose I am filling the water in a bottle and water in a bucket. You can see that when water is substituted in a bottle, it will acquire the shape of the bottle. But similarly, if water is filled in the bucket, it is again going to occupy the shape of the bucket. It means we do not have a definite shape of the water. You can see that if water is spread on the floor, it will going to acquire any of the shape it can be acquired. So it is not having a definite shape, it will occupy the shape of the container in which it is placed. So it has definite mass and volume, but it do not have a definite shape. So let's move to the properties of liquid we have. So now let's move to the next category we have, that is about characteristics of liquid. So our next topic is about characteristics of liquid. So liquids are those substances which have definite mass volume, but we can say that do not have definite shape. Next, if I am comparing with the solids, the intermolecular distances between the molecules of the liquid is extremely high as compared to the solid, and intermolecular force of attraction between such kind of particle is low as compared to the solids. Since liquids have a tendency to mix with the another liquid and it will going to give you a homogeneous mixture, so we can see that diffusion is the another property which is shown by liquid. And if you are going to compress the liquids, it will compress a little bit more than the solids. It means they are not highly compressible, but they will compress a bit as compared to the solids. And liquids do have a definite mass, so they also possess some density, but density is low as compared to the solids. So these are the features which are quite low as compared to the solid, which is basically possessed by the liquids we have. So next point will be density is low as compared to solids. Next point is intermolecular distance is large as compared to solid. Intermolecular force of attraction is large. Intermolecular force of attraction is small, but the distance is large. Next point will be they have a tendency to diffuse into another liquid. Diffuse into another liquid, and they will going to give you a homogeneous mixture. And the last property regarding the liquids we have is that they can be compressed a bit more than the solids. So we can say that these are few of the properties we have regarding the liquids. You can see that these properties are exactly just opposite as compared to the solids we have. So these are the property of the liquid, and the examples here we can consider that if I am talking about the examples, so the examples we have water, milk, alcohol. But in case of the solids, what are the examples here? Wood, iron, ice, and so many more examples. So these are the few of the characteristics of solids and liquids. Why we are discussing these characteristics here? Because from exam point of view, a question may be arise from these topic, that what are the difference between the characteristics of solid, liquid and gas. So you have to learn every step here, because a question can be asked in any of the way, like it may be the reason assertion type or it may be the theoretical part, as I have discussed here. Now let's move to the next properties we have. The next properties we are going to discuss about the gases. Nitrogen, oxygen, carbon dioxide. You have heard about the numerous gases that is present in the atmosphere. But what properties are possessed by these gases? Let's discuss here. So our next category will be about the gases. So what are the examples of gases we have? We have a numerous gases present in our atmosphere like O2, N2, carbon dioxide and many more. Now what are the properties possessed by the gases? You know that gases are those substance or those elements we can say which have a neither definite shape nor definite volume. It means again when you're going to fill a gas in the container, it is also going to occupy the shape of the container. It means neither it have definite mass, neither it have any definite shape. But we can say that the volume of the gas is always definite. So it can be observed, you can see in the LPG cylinders, we can get only 14.8 kg gas. It means the gases are compressed and fill in that container. It means their volume is fixed. So we can say that the volume of the gases is fixed, but they do not have definite shape, definite size and definite mass. So the first feature about gases is that they have definite volume. The volume is definite, but they do not have definite shape and size. And they are going to take the shape of a container. Next property is that in case of the gases, the intermolecular distance is very high. This property makes the gases much compressible because the particles of the gases are very separated from each other. So the intermolecular distance is very high. Intermolecular distance is large in case of gases. But if I am talking about the intermolecular force of attraction, the force of attraction is extremely low as compared to solids and liquids. So, intermolecular force is low. It is extremely low as compared to both solids and liquids. If I am talking about the density of a gases is very low. Density is low. Now, if we are talking about the diffusion, gases have a tendency to diffuse into one another. That you can see in the environment. In our atmosphere, we have a variety of gases. It means oxygen, carbon dioxide, nitrogen. They all are intermixing with each other. So, large separation between the particles make them easier to diffuse into one another. So, they have a capability to diffuse into one another. So, we can say that diffusion in cases of gases is extremely high. So, the gases will be diffused or intermixed with each other very easily. Last term, if we discuss about the compressibility of a gas is very high. So, in case of gases, the compressibility is very high. Now, this feature, that is compressibility of the gases, has made its wide application in the field of variety of applications we are using. Suppose if we are using the LPG cylinders at our home, this is due to the factor that gases have a much compressibility. So, the LPG cylinders used in our homes is an example of a gas, and it is the application of compressibility here. Next one, you can see that we are using the oxygen cylinders in the hospitals. These are again based on the fact that gases have the compressibility. Lastly, the CNG gases nowadays we are using in our vehicles, this is an example of the compressibility of a gases. So the compressibility of the gas found its application in a wide variety in our day-to-day life. Now, this is all about the solid, liquid and gases we have seen here. Now we will see a tabular description of these type of the compounds and how the intermolecular forces and separation exist between them. Then we will move to our next term, that is about the plasma and BEC. So first of all, copy it from here so we can proceed to the next topic. So these are the characteristics of the gases we have, and here we can write that it is having an indefinite volume. Volume is indefinite, but it is having a definite mass. So this is all about the characteristics of the gases we have. Now we will see a diagrammatic representation of all these particles. So now we are differentiating between the solid, liquid and gas, and we will learn these properties that we have discussed in a shorter form, in the form of in a tabular form format. Now this table is again very important because usually it is asked in exam between the comparison between the solid, liquid and gas. So the first property, firstly we will see the diagrammatic representation of these particles. So here I am describing about the properties. Here we will write about the solid, then liquid, and here we will have a gases. Now, firstly we will see it by a help of a diagrammatic representation. Now, this is the arrangement of particles in case of solid, liquid and gas. Now you can see that if I am placing any of the solid in a container, you can see that how tightly the structure of the solid is. It means in solids, the structure is very rigid, the molecules are very tightly packed. It means they do not have any intermolecular separation between them, but the force of attraction between them is very, very high. If I am going to compress them, the compressibility is very, very low. Now, we have one new term, that is about the kinetic energy of the particles. Now, what actually the kinetic energy is? Kinetic energy of a particle is due to its movement. It means when any particle is in motion, it will going to possess the kinetic energy. Now, in case of the solids, the kinetic energy we have is very low. It means in case of the solids, the kinetic energy, we have a very high, but in case of the gases, we have the energy very, very low. So, we will define all these terms in a simplest form with the help of this table, but firstly, we have to understand the arrangement of the particles in all the three cases. Now, you can see that in case of the liquids, the molecules are far apart. It means we can say that the structure is not very rigid and the molecules are not very tightly packed. But you can see in case of the gases also that the distance of separation between the particles is extremely high. So, it will not going to possess much force of attraction between them. So, this property, that is, gases have the property to compress very easily, gases have the property to diffuse with other gases very easily, will make it applicable in case of the LPG, CNG and the oxygen cylinders we have discussed. So, this is all about the arrangement of the particles. Second factor, if I am talking about compressibility. If we are talking about compressibility, so in case of solid, the compressibility is very low. In case of liquids, it is bit high, but if we are talking about the gases, it is very, very high. Gases are highly compressible. Now, the third property is about density we have discussed. Density in case of solids is high. In case of liquids, it is low. And in case of gases, it is very low. Next property we are discussing is about intermolecular distance. Intermolecular distance between the particle of solid is very low. In case of liquids, it is large. And if we are talking about the gases, the distance is very, very large. So, we can say that it is very large. So, here we have defined the four property of solid, liquid and gases. We have many more properties here. So, these are the few of the properties we have written here. Now, firstly, you can copy it from here. So, we can write many more properties we have regarding solid, liquid and gases. Now, I am writing the next properties here. The next property we have, that is property number 5th, it is about diffusion. So, if we are talking about the diffusion, in case of solids, we do not have any diffusion. So, we can write it here that it is having a negligible diffusion. In case of liquids, we have a very small diffusion. So, we can write here it is noticeable. So, here we have a negligible diffusion. Here the diffusion is large, and in case of gases, we have a diffusion that is very, very large. So, this is about the diffusion we have. Next property we have is regarding shape. solids have definite shape. Liquid and gases do not have a definite shape. They will occupy the shape of the container in which they are placed. So we can write here, these are having indefinite shape. Again, it is having indefinite shape. Now, next comparison will be done on the basis of nature of the particles. In case of the solids, the particles we have are rigid. These are the rigid particles we have. In case of the liquid, you have seen that the particles have a separation between them. So, the particles are not rigid. So, the particles, if they are not rigid, we can say that they are called fluid, because we have gone through two terms, that is about the rigidity and the fluidity that we have discussed in our previous class. Now, gases are the fluid and liquids are also fluid because they have the tendency to flow very easily. So, they are also fluid, but they are highly fluid. So, this is the property that is based on the nature of the particles. Now, the last property we are discussing here will be about the kinetic energy. So, the kinetic energy in case of solid is very, very low, because the particles do not have a tendency to move. So, the kinetic energy in case of solid is low. In case of liquids, it is bit high. But in case of the gases, the kinetic energy of the particle is very, very high. And here we can write here very low. So, this is the next property we are defining here on the basis of the kinetic energy of the particles. And the last property we have is that it's about the intermolecular force of attraction. So, the force of attraction between solid particles is very, very strong. It is bit high in case of liquid, but in the gases we do not have any force of attraction between the particles we have. So, this is the tabular description between solid, liquid and gases, and again this table is very important to remember. So, go through each property very thoroughly so it might be clear to you. Now, we have also discussed that compressibility of the gases has found its application in the three areas. So, what are these applications? So, you also have to remember these. These applications are in LPG cylinders, CNG gas and oxygen cylinders that are used at hospitals, and in oxygen cylinders. So, these are the three applications of compressibility which make them easier to use in these three fields. Now, we are left with the two type of the solids, two type of the particles in our nature, that is fourth and fifth state of the matter. The fourth and fifth state of the matter, you are not aware about it. So, we will discuss it now. That is about the plasma and BEC. Now, you will ask me, ma'am, that what actually the plasma and BEC is. So, let us consider it with the simple practical examples we have. You have heard about a plasma TV. Nowadays, the TV screens we are using, it is mentioned there that these are the plasma TV. Now, what that plasma is? You know that stars are shining because of the component that is filled in them is plasma. That is not the plasma that is present in our blood. It is extremely different. It is actually formed by the ionization of the gases we have. So, this plasma, do not relate it with the bio, that is the blood present in the plasma or the plasma present in our blood. So, this is not that plasma. So, plasma we have is basically the particles which have the tendency to illuminate. So, we will discuss our next characteristics, that is about the plasma and BEC. So, let's move to the next topic we have.